talked about cache expiration and cache eviction. We know while the expiration is about when to mark a cached item as stale, eviction is about removing or replacing those cached items. And in this section, we will talk about cache eviction. Here on the slide, we see different boxes where each box represents an eviction policy. An eviction policy is an approach that can help us to formalize the logic that we want to implement in order to evict the elements from the cache. And we will cover all of these policies in subsequent videos. The first eviction policy is least recently used, also known as LRU. This policy says that when the cache reaches its capacity, that means there is no more room for the new elements. If we have to add a new element in the cache, we have to remove an existing one. In that case, we always remove the least recently accessed item. The point is, how do we decide which item is the least accessed item? To do so, we often keep track of the order, that is mainly time-based order, in which the items are accessed. And we always evict the items that haven't been accessed in the longest time. That's why the name is least recently used. As an example, consider we are storing the recently accessed web pages. So whenever the user accesses a page, we always check the cache first. If we find the item in the cache, it's fine. Otherwise, we add the new page in the cache. Now, when the cache reaches its capacity, when the cache is full and the user accesses a new web page which is not in the cache, in that case, we have to add a new page. And to make the room, LRU policy will evict the web page that hasn't been accessed for the longest time. That means the page which was accessed the earliest. Let's understand the LRU policy with the help of an example. Suppose we have an empty cache, and this cache can store at most 3 elements. So that means the maximum size of this cache is 3. And suppose we found the first cache miss, so we added the first element to this cache. And here is the first element in this cache. And we know that we have to maintain the access order, which is generally the time-based. So we not only just add the item to this cache, we also maintain the access time. So let's say at time 2, this item was added to this cache. After some time, we found another cache miss for another item. And now we have to add that item as well. So we added another item, which is item number 2. And we also store the time. For this, let's say it was added at 2:10. All right. Now we have one empty slot, so we can add one more element. And as the time goes on, we found another cache miss. And now we have to add the last element or another element, which is 3. So item number 3 comes. We can add this element to this cache because this has an empty slot. And we also store the time, the access time. Let's say in this case, this is 2:20. So right now this cache has 3 elements and each element has an access time. Item number 1 was added at 2. Item number 2 was added at time 2:10 and item number 3 at time 2:20. All right. Now suppose we have to add a new element to this cache. We cannot do it because there are no empty slots. So in order to make room for the new element, we have to evict one of the existing items. So out of these 3 items which are already in the cache, which item should we remove? The LRU policy says that the least recently used item should be evicted. But how do we make sure that the item that we remove is the least recently accessed item? The good thing is because we are also storing the access time, we know that this item was added at time 2, but it has not been accessed after 2. So this is the item that has not been accessed in the longest time and we can safely remove this. So as per the LRU policy, this item will be removed. One empty slot will be added to the cache and so we can add this new item, let's say at time 2:30. All right. So this is the simplest case with LRU policy where we have an item that can simply be removed as per the recorded access time. All right, moving on. Let's expand the same example and cover another scenario. So we have the same cache with the maximum size 3, but at time t, this cache is empty. And same as the previous case, we added the first element to this cache. This is the first element and let's say this item was added at 1:15. All right, after some time we found a cache miss. So we have to add one more element to this cache. And here comes the item number 2, which is added at 1:30. We have one more slot, so we can add one more unique element to this cache. And let's say we have item number 3, same as the previous case. And this time this comes around 1:45. So we have 3 items in the cache and each item has the access time recorded. Now, let's say after some time, the application tries to access the same item, which is the item number one. So in this case, because the item already exists in the cache, it will be a cache hit, and the item number one will be returned from the cache rather than going back to the original data source. But in this case, there is one more thing that we will do. Because the item number one is a cache hit, so we will not only return the item from the cache, we will also update the access time. So let's say the previous access time was 115. We will change it to the latest access time, which could be, let's say, 150. So at time t1, we still have the same three elements, but we updated the access time of item number one from 115 to 150. And now if we have to add a new element, let's say a new item comes because the cache is full and we have to remove an existing element. So we will again apply the LRU policy and we will find the item that has not been accessed in the longest time. All right. And in this case, this is the recently accessed item now. And the second recently accessed item is item number 3. And in this case, item number 2 is the item that has not been accessed in the longest time. So this is the item which is the least recently used, because earlier it was item number 1, but because there was a cache hit, so we updated the access time. And in this case, the item number 2 will be removed and this new item will be added to the cache. So that's how the access time works. That's how we maintain the access time of the elements. And by keeping the access time information, we can safely remove the least recently used item. In order to implement any eviction policy, we need to understand the access pattern. So in the scenarios where we think that the recently accessed item will probably be accessed again very frequently, in that case, we can use the LRU policy, because the recently accessed items will always be hot in the cache. And by maintaining that, we can always remove the least recently accessed items whenever required.